Worksheet number 2, logarithms. These are the notes, yeah? So what did we learn in the first worksheet? Well, you got to learn how to, you understood and you're reminded what an exponential notation or form is. But then why do you need to learn and know this logarithmic form? Well, because the problems are going to be given to you in logarithms. And that's not your language. You don't speak logarithm. That's not your language. You have to translate it back to what? Exponential, right? Like if I give you, right, let's just review a little bit of yesterday. If I give you log 232 equals 5. I need to have these pieces, right? I need to have these three numbers. I need to have the three numbers. I can't just have 2, right? Can I just have 2 like this? No. You got to have all three pieces. Now, how do you change this? See, I don't understand this. I don't work in this language. I need to change it to to my language, to this exponential form. How would you change this to exponential form? Remember I talked about this yesterday. You look at this counterclockwise. You start with the base, which is 2. 2 to the power of what? 5 is equal to what? 32. Is that a true statement? Is 2 to the power of 532? That would be 2 times 2, which is 4, times 2 is 8, times 2 is 16, times 2? Yeah, it is. It is 32. See, it's gonna hold true. Okay, so the point is you don't work in logarithms. Your problems are going to be given to you in logarithms. You got to change them into what? Into this, because you totally understand this. Right? This is a lot more easier for you to understand than this. Now, yesterday on the third piece, on the third set of problems, you had a problem like this. It didn't have all these three parts. You had this. On yesterday's assignment, you had something like this. Log 2/8. This is from yesterday's homework, the last part, not the part where you had to change from exponential to logarithm. Anybody saw that third video and know how to do this? Exactly. You know why you don't know? Because it's in logarithm. This is a logarithm. This is new to me. I don't understand this language. If you show me this in my language, in exponential form, I can get it. I'll figure it out. What's wrong with this? Everybody can tell me what's wrong with this? It doesn't have what? Well, you know how it has to have three parts. Doesn't it have to have three numbers like this? See, this is where you're going to have to solve now. This is where you're going to have to solve. One of the numbers is missing. So actually, what do you have to do? You actually have to put, what do we usually use for a missing, something that we're going to solve, something that's missing? Don't we put an X? Don't we put an X for like what we're trying to solve, right? That's like the common popular letter that they use. This should have an equal sign. Isn't it missing something here? Yeah, see, it's missing it's missing a number here. This is not the way it was explained in the video, but I'm explaining it to you now. If it's in logarithmic form, I don't understand this form. I'm going to change it to exponential and I'll understand it. But there's a missing part right here. Yeah? Now, does everybody agree I have all three pieces? Yeah, even though this is not a number yet, right? We're going to solve that number right now. And then now, I'm not going to solve it in logarithmic form. This is what's new to you. You're not familiar with this. This is strange to you. But when you change it now to exponential, I want you to work in exponential. That's the language you know. Can somebody tell me how to change this to exponential? Well, again, wouldn't you start with the base and you go what? Counterclockwise. So what do I write? How do I write this in exponential form? 2 to some power, right? That's the part that we don't know. That's the part that's missing. 2 to what power equals what? 8. Equals 8. Does anybody know that answer? Andy? No, that's not Andy. You're David. Sorry, Andy. Sorry, David. It's 3. The answer is 3 because 2 to the power of what is 8? 2 to the power of 3 is 8. See? So, yeah, x is equal to 3. That's how you're supposed to do the ones from yesterday. Let me give you another one. What if I put this? Again, this is the ones from yesterday. Log. Again, see, they're gonna put you the problem. They're gonna present the problem in logarithmic form. You don't know logarithmic form. Change it to exponential, and it makes sense to you. Okay. What if I tell you log 6 36? Well, first, before I do anything, I know this one's kind of easy. Believe me, they're going to get a lot more complicated. I know this one's easy. You can probably do it in your head, but just let's go through the same steps, yes? It's missing something, right? In order for me to change it to exponential form, you got to go log 6 36 equals what? What do I put for the part that's missing? Equals x. And then change it to what? And then change it to exponential form. Right? Because I don't want to work in logarithmic form. You're going to be your masters. You guys are experts in exponential form. Okay, so what? How do I rewrite this? I got to rewrite this in exponential form. Wouldn't it be 6, right? Counterclockwise again. 6 to what power gives you what? 36? Oh, now that's easy. See now how easy it is when you see it in this familiar form, the exponential form? 6 to what power is 36? Oh, the answer is 2. So that's going to be the big thing I'm going to emphasize. These are easy. These here for this first worksheet were kind of like the super easy ones, and they give you a nice answer. It's not going to be like that when we see these next problems. Maybe not today, but okay. So now let me give you the notes of today, and you'll see how it's like the same thing, right? Let me give you, this was kind of reviewing yesterday's homework and how you had to do that third part. Here's the assignment for today, for worksheet 2. Watch how it's really emphasizing the same thing. Why am I going to teach you a bunch of different ways to do different things when one way can if I just show you the same way and it applies the same way all the time, it's easier for you to remember that. Here's number 1. We're going to do these quick because they're so easy. Here's what your problems are going to look like. And it's going to say solve, by the way. Number 1, log 3x equals 4. Is this one missing anything? No. It has the equal sign. It has 2 things here. It has 1 thing here. But you're not going to solve it in logarithmic form. You're going to change it to what? Okay, tell me how to write this in exponential form. 3, remember counterclockwise, start with the bottom with the base. 3 counterclockwise is this way, right? 3 to the power of what? 4 is equal to x. Do I need to solve for x? It's already isolated. It's already says x equals this. X is equal to whatever this is. That's it. You don't really need to solve anything. X is what? What's the answer for this? Whatever 3 to the power of 4 is. What's 3 to the power of 4? Well, whatever this is going to be. Anybody know what that is? 81. You see? Did anybody know the answer when I first wrote the problem and it was in logarithmic form? No, you didn't. You didn't see it. But when we changed it to exponential form, and then you solved it this way, okay, you got it. Okay, that one was kind of easy. Number 2, let's go number 2. How about this? Log 9 n, right? They can use any letters. They're going to change the variables. Equals negative 2. Right? You don't work in logarithmic form. You change it to what? Exponential. I have all the parts here, so this should read what? What should it read now in exponential form? 9 to the power of what? 9 to the power of 2 is equal to? Is equal to n. Oh, good. It's already solved for n. I don't need to solve or move anything. We talked about this. How do we do this? We can't have negative exponents, right? Hey, we can't have negative exponents, right? Anybody remember how to do this? You bring it down to the bottom, right? It can't be, it has to be positive. So it's 1 over, okay, so the answer is what? Yeah, 1 over 81. Correct. Okay, now let's see what you're going to do with this. Ready? Now, those are kind of easy. Number 3. Morning. Number 3, log 2, parentheses, x minus 7 equals 4? Sure. What is that? Exactly. You don't try to solve it and you don't try to do it in logarithmic form. You change it to exponential form. How is this equation going to look in exponential form? 2 to the power of 4 is equal to x minus 7. See, now this one I got to do some solving. There, the variable is not isolated. Okay, no worries. 2 to the power of 4, you better not put 8. 2 to the power of 4? 16, right? 2 times 2 times 2 times 2. 2 times 2 is 4, times another 2 times 2 times another 4, that's 16. 16 is equal to x minus 7. Is the answer 16? No. You got to solve for x. See, this one we do have to solve for x. X is going to be whatever 16 what? Minus 7. No, when this negative moves to that side, it turns positive. Don't be doing it in your head, see? You're going to get the answer what? 23. So what are we doing? We're having problems here that are in logarithmic form. You're changing them to what? Exponential form, and then you're solving them, right? Number 4. Okay, let's see if anybody gets this. Oh man, I remember something now. All right, let's see who remembers something right here. That's it. That's number 4. When you get the answer, go ahead and say it out loud. What's the answer, David? You think it's 1 over 6? No, it's not. Sorry, sir. Correct. Remember, some people got $5 yesterday and stole my money, and I didn't eat lunch. Yes. Remember that? What's the base if it doesn't have one? 10. If it's missing a base, you better put what? 10. They're not going to write it if it's a 10, but you have to know it. You have to know that it's a 10. If it's missing a base, it's a 10. Okay, and if that's true, now we can write it 10 to the power of what? 10 to the power of 3 is equal to? Well, is equal to, is equal to this part over here, r plus 6, yeah? Is that correct? Yeah, that's correct. And what? 10 to the power of 3, you better not put 30. 1,000. Yeah, somebody will put 10 times 3, 30. 1,000 is equal to r plus 6. What's the answer? 1,006? Yes, Quincy? The answer is 1,006? No, because if this is plus 6, what is it going to be on this side? Already doing silly mistakes. The answer is what? You see? Nobody said 994. Aren't these easy? They're easy when you change them eventually to exponential form. See, when you first see it in logarithmic form, you're not going to know the answer. Okay, last two. Ready? 5 and 6? I think you got it. 5 log base 7 parentheses 6n plus 7 equals 2. What in the heck? Look at it. Look at how complicated that looks. That is so complicated looking. That looks difficult. Well, because it's written in this language that you're not too familiar with. But when you change this into what you are familiar with, which is exponential form, it's going to be very easy to figure out. You got the answer already? You're right, it is 7. How did you do it? In your mind? You did all the calculations in your mind? Oh, very good, David. Okay, tell me what you did. How about we rewrite it in exponential form first? I hope you're thinking in exponential form, right? That's 7 squared is equal to? That's what you did in your head? Oh. That is right. Wait, you're too fast for me. You did all these steps in your head? All right, keep going. Oh. Is that right, Alex? Hmm? Then it's right. Last one, 6. 6, you got it. Oh, I don't think anybody's going to get this one. Log 7, parentheses negative 6p minus 3 is equal to negative 1. Oh, yeah. Oh, yeah. Well, I'm not going to do this in logarithmic form. You got to change it to exponential form. That's going to read 7 to the power of negative 1 is equal to? What? 7 to the power of negative 1 is equal to? Negative 6p minus 3, right? Like that. Okay. 7 to the power of negative 1 is what? 1/7 is equal to negative 6p minus 3. And this is where some of you don't know how to finish it. Anybody know what to do here at this point? Very good. When you have an equation and there's a fraction, you don't want to see a fraction. So there's a smart thing you can do to get rid of it and not have a fraction anymore. Say it again, Destiny. Whatever that number is, multiply every term by what? By that number, 7. If that term gets multiplied by 7, guess what? They all get multiplied by 7. Because it's going to clear it out here. It's going to clear it here. See, you won't have fractions anymore. When 7 divided by 7 divides out, what's left? An equation with no fractions, and then you can solve it easily. 1 is equal to negative 42p. Is that? Yeah, negative 42p minus 21. And now I'm going to do this. 42p is equal to negative 21 minus 1. Did anybody understand my move right there? I mean, you can finish it a couple of different ways, but I'm going to do that. I always like to have this number positive. So I move this over here and I move that over there. Does that make sense? Okay, so I'm going to have 42p is equal to negative 20. Ooh, 22? Yeah. That's going to be P is equal to a negative 22 over 42. And you just have to reduce it. You just reduce it by 2. Negative 11 over 21. Yeah, that's the answer that I have here. That's the answer. So you're not going to get all these perfect answers all the time. But the point was not the solving. The point was you're going to have a question, you're going to have a problem in logarithmic form, change it to what? Exponential, and then you finish it from there. All right? There you go.